Hello everyone. This video is going to about designing an inverted F antenna. So for that we have to create an variable. So add variable. Let us give a variable name L1 with 20 millimeter. In CADFEKO version 2024, all the units are will be in meters. Okay. So add next L2 with a 50 millimeter and L3 will be again 20 millimeter. So now we can give us W that will be in 5 millimeter. So we can give a gap that will be in 2 millimeter. I will say why this gap will be we are giving. So next XX box. This is for our ground planar. We can give it as 0.2 centimeter and we can give a YY box that is 0.1 centimeter. Great. So we have created all the necessary variables for designing our antenna. Now we can create the design. So rectangle. Now here this is start from the origin, that is one corner part is created. So we can make it a center. Now but this is a ground planar. For that we have to create width will be XS box as I already mentioned. Depth will be YY box. So we can create. So this is our ground planar for in an inverted F antenna. Next rectangle. Okay, done. Next. This is for our shape, that is F shape, inverted F shape of this antenna. So we can give again center. Next V will be 0.5 into L1 minus gap. Next our width will be W and depth will be L1 minus gap. Gap. Width will be L1 minus gap. We can give. Okay. Now this is in horizontal plane. We have to make it in a vertical plane for an inverted F shape. So we have to edit our work plane. So custom work plane. Here we can give a Z value will be a gap and Y will be zero point 0.1. So 1.0, sorry. Uh, uh, it will be okay. Now here it will be zero point 0 and here will be 2.0. Create. Okay. Now you can see that a rectangle, that is a work plane is now created. This is the gap, that is 2 millimeter gap. This is the 2 millimeter gap. So we can create the next rectangle. Again center as same. We can give this is as minus L by 2 minus L1 by 2. Next width will be L1. Next our dimension will be W. Next, for again changing to vertical plane, we can give x equal to L3. Here x will be zero point 0.1 and here it will be zero point 0.1. Okay, so here it will be 0 and here it will be minus 1. Create. So you can see that another a vertical plane is parallel to the rectangle 2. So we have to create another rectangle that will be in the top of both rectangle 2 and rectangle 3, which will make our F shape. So here we can give us minus L2 by 2. L2 by 2. Next this will be our L1 with okay, L1. Okay, L1 width will be our L2 and depth will be W. Okay. Now you can see that it is here. We have to move this to here. So again we have to custom our work plane. So X will be our L3. L3 will be 20 millimeter and again other parameters are the same. Okay, we can create. Now you can see that we have created an F shape, that is inverted F plane ground planar antenna. Now we have to give a wire connection to this origin to this plane. Now we can give a line. Here endpoint will be 0, here will be also 0, and here we can give gap because here here only we are giving the connection. So I have given a gap. Create. So now the line will created. We have to create a wire port because for voltage source. So create port, wire port, line 1, wire port number 1. Create. So now we have to give a voltage source for an antenna. Source load, voltage source, as same we can give create. Now we have created the voltage source. Now we have to show that the all metals should be connected. That rectangle 1, that is the ground planar, this rectangle 2, this rectangle 3, and this rectangle 4 should be connected with this line. So we have to make that union. So we have to select this 5. So we have selected all these and go to construct. Here it's an option union which makes the connection of all the metals and wires. So given. So we can see that under the we can mention it as container. Under this we have line 1, this yellow color, yellow portion, rectangle 1, rectangle 2, rectangle 3, and rectangle 4. So now we have selected. Next we have to give the frequency for an antenna. So we have to go to source load frequency. So you can give a linearly spaced. Next we have to give a 1 gigahertz, 1e9, and n frequency is 2 gigahertz. Let's give a number of frequencies 51 and apply. Okay, now we can see that small rectangles are forming our ground planar and our all the rectangles. This shows that meshing of our antenna, that is auto mesh. We can see automatic meshing of our antenna. So now we have to request current. So we have to create current and far field. Far field can be a 3D plane. So 3D plane create. So you can see that in 3D plane. So this is our far field of our antenna in 3D. Okay. Next, we have to run this. So for running this, we have to first save this. So I save this in desktop as oh, hmm, saved. Now this is saved. So we have to go to solve for Pico solver. So you have to solve this. Can wait for just a minute. Mhm. It will take little time. Mm. Okay. Then so now we can go to to check our working of our antenna. So this is the image of our this is design of our inverted F antenna. So now we can give okay. Now this is our design. We can check our far field. So we can drag this far field and place it here. So this is our total gain, that is 3 3 dB. It is not in a dB, that's 3 for 1 gigahertz. So we can keep it file just for 1.5 1.5 and then dB. So this this is the Antenna gain, inverted F antenna gain, that is 5 dBi, maximum of 5 dBi. Next, we have to see the voltage source. So we have to go to Cartesian graph. Okay, we have to drag the voltage source. So this is our voltage source. So we can make it as a dB. So we can see after 1.5 gigahertz, we have a reflection coefficient dB of voltage source 1.5 to 1.6. So this is our Cartesian graph. Okay, these are the graph of voltage source, and this is our gain. So we can see the movement of current. Okay, so we can hidden this far field and we can place our current here. Current. So we can make animate face and play. 1 minute here. So, so we can see our face and the movement of current. This is a movement of current in our antenna. Okay. So we have seen our design and the post working of an uh, inverted wave antenna. So this is a type of antenna commonly used in wireless communication, such as in our mobile communication network, mobile phones. We have used this type of antenna. Mm, it's mostly a type of an monopole monopole antenna. Okay, these have a ground planes and two vertical plane and one a horizontal plane. The advantage of the inverted F antenna is it is compact and lightweight, so you can easily integrate it into a circuit board for an electronic devices. So offer they offer moderate to high bandwidth and omnidirectional radiation. So we can say that most of the main application is due to their small size and efficient performance. They are widely used in mobile phones, wireless routers, and other portable devices. Okay, thank you.